Okay, so the main idea what I'm going to do right now, you know that this drive contains a damage head, and it's very dangerous to make a full sector by copy, full sector by sector copy right now, because if we will try to do a linear copy from this drive might become dead, because if one head is not working correctly, it can scratch the surface of the platters. That's why it's very important to switch off damaged head and start imaging of drive only by healthy heads. And how we can do that? Actually, we can do it very simply. First of all, we should connect to portable system the drive that I am going to use like a source. So I'm going like a destination drive. So I'm going to do a full sector by sector on port number 1. Let me make power supply on port number 1 and refresh the drive ID. Let's see, do we have anything here or not? And we successfully get the information that this drive is 3 terabyte capacity, and we are going to use port number 1 like a target drive to where we will make a copy. So after that, I'm going to launch imaging data function and start copying process. But of course, it's not all, because we should create a new task in data extractor, and we have to build the heads map. Heads map will include all information about the heads which are presented in this drive. And actually, heads map building will take some time. We have to wait a bit. And during this time, I just want to say that heads map building is a very convenient way, because here with the heads map, we can switch off damaged heads. We can do a copy of data by healthy heads. And after that, when the copy by healthy heads will be done, we can return back to bad head, and very, very slowly, using different timings of PC3000 data extractor, we can try to very slowly try to read the most important data by damage head if it's not completely dead. And of course, in this case, probably you will not get 100% image from this drive, but if we have a goal to see at least what is the content inside, what evidence located at this hard disk drive, and is it make sense to move forward with this case. So probably it's not interesting for police, for our or probably our user. What we are going to do in this case? Of course, we have to buy a donor drive, swap the heads, and so on. But if we don't have a donor, we can try to get at least a partial result of recovery using this head map feature. And of course, if our drive is not completely dead, if even the damaged head is partially working, we can try to play, as I said before, in data extractor with settings, and very slowly start to make a copy by damage head also. So our head map is built, and now we should return back to automatical checkup and see which head is in a bad condition. And here we can see that our damage head is head number 2. So in imaging data option, I am going to switch off head number 2. And now I am ready to do a copy by head number 0, head number 1, 3, 4, and 5, which are absolutely healthy. And I am starting the copying process. And here in map, I can see that our data extractor is using only healthy heads, while the head number 2, which is failed, is not going to be a part of copying process right now. So this is the way how we can make a sector by sector copy from damaged drive, even if one or more heads are damaged or corrupt. Let's speak about the damaged head, what we can do with our damaged head. Actually, I can switch off all healthy heads while the full copying process will be over. Then I can switch on head number 2 and play in data extractor with different settings, like for example, how many rereading attempts I'm going to apply for every bad sector. So I'm going to try reread the same bad sector 10 times. Probably after some times of reading, it will be possible to read a correct value of sector of LBA from the surface of drive and get a working LBA. So after that, I'm going to play with timings and improve it, because sometimes if our head copying speed is not fit into timing process, there might be a bad sector. But if we will increase the timings, if we will try to read the data slowly, probably less bad sectors we will catch on the way. So I'm starting with head number 2 only. And you can see that right now I'm starting the copying process, but this process goes very slowly. And of course, we get a lot of bad sectors, but during several attempts of rereading, we can read the data even from bad sectors. So you can see here we get a bad sector, but after reading attempts, this black sector become green sector. So very slowly we can move forward and reread the surface on this drive. This is how we can communicate with the HDD in case if we have a problem with surface or if we have a problem with heads. What else in the end we can do here? The most convenient thing, I suppose, so that we can launch the report function. If I will press at report, I would be able to generate a full report about the drive condition. And this report will include information about our tool, about our software version. It will include information about the drive that I am working with, power consumption, all other information about smart parameters, about data access, about technological mode with the information about the user password which was set here, and of course the heads condition, because you remember that we have 6 heads, and head number 2 is damaged and contains a lot of bad sectors on the way. In the end of report, we also can get information about how many sectors we successfully read, how many sectors we were not able to read because these sectors are bad, and how many sectors left for copying process. All this information will be available for us inside the automatical report. This is the things that I'm just going to tell about the easy mode. So right now, let me exit from easy mode, and we will start to speak about the full feature mode. Okay, so the full feature mode, just a few interesting things about it. So what do we know about the full feature mode? As I said before, full feature mode is the same as in Express and UDMA, but it also contains some features like USB host port and NVMe PCI Express SSD support, and of course we are going to speak about it. And the first feature that we are going to discuss will be a USB host port. You know that there are a lot of USB drives, like USB hard disk drive, like USB flash drive, and so on. And we can contain all this information. We can put this information inside. We can collect these drives. We can connect these drives to a USB host port and analyze. But actually, what is the difference between a common USB port in your PC and USB host port in portable system? There is a huge difference, because if we talk about the USB port in our computer and we connect USB drive to it, we should remember that there is some special power supply settings which become controlled by your motherboard or by front panel of your computer. Also, there might be an influence from the driver in operating system, because driver also can provide some additional checking procedures, some VID readings, some verification, protocol commands, and so on. And finally, operating system, which might influence on our damaged USB drive. All these parts are influenced, might be critical for damaged USB drive. And for example, there might be the situation when you connect the drive to your computer and it's not detectable. But with the help of PC3000 USB host port, which is located inside the portable system, we get a full control of power supply functions. We get a full communication, direct communication between portable system and USB drive. We don't have any operating system influence. We don't have any background activity from the operating system, and we are able to send the technological command via the USB host port. What does it mean? It means that sometimes if we are working with custom or native USB hard disk drive, we even shouldn't try to swap the PCB, solder the SATA connection on it. We can just connect such drive via USB and work with this drive via the USB host port without any problems. So it will be fully working and data recovery will be possible. Which problems we can solve with the help of USB host port? We can solve such problems like unstable work via the USB, freezes in operating system, like not responding from USB port from our device or from Windows operating system, like hanging, like freezing of the operation system. We can deal with logical corruption and with bad sectors. So we can very effectively read the bad sectors on our USB drive. And such drives like a custom and native USB HD and SSD are supported. We can also work with USB sticks, USB flash drives, and we can work with SD, secure digital, and micro SD cards with the help of special card reader, which is included inside the PC3000 portable tool kit. And now let me show you the demo. Actually, I have here a small USB flash stick. It's just pretty small, a normal 8 GB Transcend drive, and I am going to plug it directly to my computer. So let's see what do we have here. I am connecting, but unfortunately it's not possible to reach the data which is located at this USB drive. I'm trying to do that, but software tell me that please insert a disk into the USB device. And of course, it's not operatable here. But if I will try to connect this drive to our USB host port, I can try to see, probably we get some better result, better recovery. And let me launch portable tree system. Use USB port as the main port here, and start the software utility. So after that, we are ready to make a power supply on. And let's launch universal utility. Let's see, do we have a passport ID for this drive or not? And we can see that, yes, we have a passport ID, we have a full capacity of this drive. So let's try to use our data extractor software add-on to recover data from this faulty USB flash drive. We're going to data extractor. We make a new task. Let's call it USB flash. Then we are going to use USB PC3000 USB host port as a source port. And let's see, do we have a folder structure or not here? And of course, as soon as I will try to open the folder structure, I've got an error, and our software asks us to launch a quick disk analysis to look for a missed partitions. I press yes, I would like to do it. And I'm going to use all possible file systems which might be located at this flash drive. So we're going to look for a signs of the file system presented on this device. And I'm started software trying to look for file systems which might be missed from this drive. And after a short period of time, we get a partition with data. So if I will try to exit from here and expand the folder structure, I will see our missed partition. And actually, files should be openable. We can see all information from the drive here. We also can try to open some PDF file, like, for example, I don't know, maybe this one. it's a 6 megabyte PDF file, and this file is openable, so we get access to user data. And of course, after that, we have to save all content from this USB flash device, which is logically corrupted. And for doing that, we can select the root folder and save all files into our folder that we need. Or probably, if we want, we can do an imaging, and we can try to export the image into another drive, do sector by sector copy. We can export it into a binary file and analyze it later, or we can use export into forensic format. And actually, we support a lot of different forensic formats, like advanced forensic format, like in-case forensic format, smart in-case forensic format, and so on. And we're going to use one of these to make a sector by sector copy into a forensic format image. And after that, with the help of third-party tool, we can analyze this image and search for some specific files by keywords if you want. This is how we can work with logically damaged USB flash stick, which is contain a problem with partition. Okay, and of course, the last task that I want to demonstrate for you, it will be a pretty interesting case about the NVMe drive. Actually, right now, PC4000 Portable can work with all type of SSD drives, no matter what type of bus is it. It might be a common SATA drives, it might be PCI Express drives, or it might be PCI Express NVMe drives. And in nearest future, we are going also to add ACHI drives, which are actually very popular in MacBook computers. And right now, we already announced the Apple MacBook PCI Express adapter, which will allow you to recover data from logically damaged MacBook drives. Because the main problem when you get the MacBook, like MacBook Pro with Retina display, like MacBook Air, the main problem is that sometimes you don't have a proper adapter just to plug it and to some system, to your computer. And of course, there might be some additional problems connected with unstable working, bad sectors, problem with file system. But of course, with the help of portable system, you can do that, because our portable system is based on the latest modification of CPU, which is installed inside. And this CPU is very powerful, and it contains a lot of interesting features like PCI Express support, like PCI Express lines, like ATA lines, and so on. So we can use it for SSD also. And in our example, I'm going to show you how we can work with HP AX900 drive with 500 gigabyte capacity. These drives are based on Silicon Motion controller, but HP company, Hewlett Packard company, they just rename the controller name and do it and name it a little bit differently. So I am going to use our red M.2 adapter. It's look like this. So this is actually absolutely the same drive like on the picture on my screen. And this drive is connected to our M.2 NVMe adapter that I'm going to plug to portable system. And let's take a look how we can work with physically damaged drive where the SSD contains some firmware corruptions. So let me connect the drive to portable system and launch full feature mode. So here I'm going to use M.2 NVMe PCI Express SSD. And after that, we need to launch the power supply. The interesting thing is that this drive is NVMe, this drive is PCI Express. That's why there is no any ATA registers like usually we have while we work with hard disk drive or with ATA SSDs. Here we have just a few of registers, and they are not looks the same as in ATA hard disk drive and SSDs. And let's see the universal utility. What do we have inside? Do we have any passport ID or not? And we can see that this drive is detectable. but instead of HP AX900 family, we can see here just a limited capacity, just a wrong model name, and unfortunately, of course, data will be not visible here. If I will try to edit some sectors and read some LBAs, I can see that all LBAs contain the same pattern. So it means that actually we don't have access to user data here, because this drive is corrupted and we can't read anything from it. What we are going to do in this case? Actually, we can try to launch one of the special utilities for HP drives for HP controllers. And after that, we can try to switch our drive into technological mode. For doing that, we need to upload a loader inside the drive RAM. We're not going to work with ROM chips or with NAND chips. We're going to work only with RAM, which is absolutely safety, even if we talk about the forensic case. So I'm going to upload the loader inside the RAM. Some time we need to complete the drive initialization. And here we can read some additional information about current SSD. For example, we can read information about chip IDs, about the vendor, about the manufacturer of these chips. We can read information about the type of this memory chip. It's a TLC memory chips, triple level cell NAND memory chips. We can read here information about the chip capacity, how many NAND memory chips do we have, and some other information which also might be useful for research or for some other things. So what we can do here, we can try to save the dumps from this drive and analyze it with the help of special tools, for example. Actually, this is the same action as a chip off, but without a chip off. So if we want to save the dumps from this SSD drive, we shouldn't do a chip off. We just need to launch the dump saving feature and it will be enough. Or we can try to get a full access to user data with logical translator rebuilding. And for doing this, we just need to follow by data extractor. After that, we need to make a new task. And let's choose our SSD like a source. So our software in the background will try to build the translator, and this translator will be also uploaded into RAM. After that, when drive will be into the technological mode, it will be possible to work with this drive. It will be possible to communicate with it. And theoretically, we should get a full access to user data. I can say that recovery of damaged SSDs in PC3000 is very simple. The main feature is that your drive should be supported by our software. If it's supported, recovery will not take too much time. And again, here we can see a complete image. We can see here even some photos, and I can try to open them. And looks pretty good. So we get the data from this drive. If, for example, we need to make an image, and again, we can do a sector by sector copy to another drive, we can export it into a binary file or into forensic format like the USB flash stick that I showed you before. This is how we can work with physically damaged NVMe SSD drive with serious firmware corruption. And of course, I would like to say that our developers are working on the new families, and in the nearest time, we are going to add a Marvel-based SSDs and a new generation of Phison-based SSDs based on NVMe technology into the PC3000 portable tree tool. Okay. And finally, of course, I would like to say that full feature mode allows you to recover data even from the most complex cases. And if you get a really complex cases, most likely that you will need a full feature mode to work with it. But If you don't have experience with PC4000, this mode might be too heavy for you, probably too complex for you. That's why our company provides a pretty good technical support, which can offer to deal with damaged drives. We also can help to handle with the most complex cases, and of course we provide some trainings. And right now we already going to launch the online trainings, which might be very, very useful. And of course, our partner, MIT company in Republic of Korea, they also provide offline trainings for hard disk drive recovery, for flash recovery, and SSD recovery. So if you are going to buy PC4000 equipment in future, it's a good idea to visit the training, online training, offline training, to get as much knowledge as you can, and then start your real practice with physically damaged storage devices and PC4000 systems. So thank you very much. I hope that you enjoy my technical part of presentation. And right now I am giving a word to Elena Shulga, CEO of Ace Lab company.
No.
So I can start. Do you hear me? Good.
Yes, we can hear you. Yes, please.
My presentation.
Okay.
Okay.
Dear Roman,
So, okay.
thank you for the wonderful lecture. And then many engineers and many other people are attending this webinar, many reviewing the attendees. And then thank you for the painstaking work. And then it will be of much help to engineers and even to the beginners can follow the if they follow the what Roman guide us, and then they can use this PC3000 tools well. 그래, 지금 그 로만이 발표하신 거 잘 따라 하게 되면 그 툴을 가지고 잘 활용할 수 있을 거라고 생각합니다.